So this is Jacob's Algebra, Chapter 10, Lesson 2, Part 2. We already finished covering through number 7 in the Part 1 video. So what we're going to do now is start with number 8. Number 8 is just like number 14 that I assigned as homework. And what it says to do is tell what monomial should replace the shaded area in each of the following to make it true. So we're going to look at Part B, which says 2x squared times something, which we need to figure out, is equal to 10x to the 10th. Well, first we should look at the coefficients. What do we have to multiply by 2 to end up with 10? Well, that's a 5. And then what do we have to multiply by x squared to get x to the 10th? That's going to be x to the 8th. So 5x to the 8th is our answer for 8b. For 8d, the problem is negative 7x times something is equal to 21xy. So first we look at our coefficients. We have negative 7. What do we multiply by negative 7 to get a positive 21? Well, that would have to be a negative 3. And then what do we have to multiply by x to end up with xy? Well, we already have an x, so all we have to put here now is a y. So negative 3y is going to be our answer. The last one we're going to look at is part F, which is 2x cubed times 3x squared, and then times something is equal to 12x to the 12th. Well, this one is a little bit harder because we have two things that we need to multiply in addition to the thing we're trying to figure out. So I'm going to go ahead and multiply these two terms by each other. So 2 times 3 is 6. X cubed times x squared is x to the 5th. Now we multiply that by our unknown to end up with 12x to the 12th. So what do we have to multiply 6 by to end up with 12? That answer is 2. What do we have to multiply x to the 5th by to end up with x to the 12th? That answer is x to the 7th. So our answer for this problem is 2x to the 7th. So that was number 8, which is just like number 14 that I assigned for homework. Now let's look at number 9. Number 9 is just like number 15 that I assigned for homework. It says find the greatest common factor of each of the following sets of monomials. So we're finding greatest common factor here. So the first one we're going to look at is 9b. And the two numbers we're given are, well, the two monomials we're given are 10x squared and 45x. Well, I can immediately see that I have x in both of these. So I know that x is going to be part of our greatest common factor. And then what else is in common between these two? Well, 10, we can get 10 by multiplying 2 by 5. We can get 45 by multiplying 9 by 5. So 5 is a common factor there. So definitely 5x will work. Is there anything bigger than 5x that will go into both 10x squared and 45x? The answer to that is no. So 5x is indeed our greatest common factor. Okay, so next we're going to look at part D. We have x to the 7th and x to the 17th. Okay, anytime you're given things with powers, you need to see which one is the smallest power. The smallest power here is x to the 7th. So x to the 7th goes into x to the 17th, x to the 7th times. So x to the 7th is going to be our common factor because we can write x to the 7th as 1 times x to the 7th, and we can write x to the 17th as x to the 7th times x to the 10th, and that would make x to the 7th a common factor. Okay, part F is 33x, x, and 44y. So if I break down our coefficient on 33x, we have 3 times 11, and then we have times x. If we break down the coefficient on the 44y, we get 4 times 11 times y, and we could break this 4 down into 2 by 2. But what we can see that's a common factor is the 11. The 11 is the only common factor in 33x and 44y, so that's our greatest common factor. Okay, let's do just a couple more. Let's look at 9h. We have 52x squared y squared and 13xy cubed. Okay, let's break down the 52. 52 we can write as 4 times 13, or we can write that as 2 times 2 times 13. And then the x squared, of course, we can write down as x times x, and the y squared is y times y. When we're breaking down 13xy cubed, we can write that as 13 times x times y times y times y. So now we see what's in both lists. Well, both lists have a 13. Both lists have an x, and both lists have not just one, but two y's. So our greatest common factor here is going to be 13xy squared, because 13 appears once in each list, x appears at least once in each list, and y appears at least twice in each list. So 13xy squared is the greatest common factor. Let's look at number 9J. Whoops, that's a 9. Number 9, part J. And that has 6x squared, 9x, and 3. Okay, so breaking down 6x squared, we have 2 times 3 times x times x. When we break down 9x, we get 3 times 3 times x. When we break down 3, all we have is 3. So the only thing that's in common on all three lists is the number 3. So our greatest common factor for these three numbers is 3. And the last one we're going to look at is part L. Part L has the numbers 4x cubed, 12x squared, and then 6x. So 4x cubed we can write as 2 times 2 times x times x times x. That's supposed to be an x at the end there. 12x squared we can write as 2 times 2 times 3 times x times x. And then 6x is 2 times 3 times x. So what is in all of these lists? The only thing that appears in all three of these lists is the x. So you might be tempted, if you look just at the first two, that it might be 2 times x, or 2x squared, because 4 and 12 are both even numbers. Oh wait, there's a 2 in these also. I take that back. So 2x actually is our common factor. All three of these numbers are even, so 2 goes into all of them. And then each of these numbers has an x in the factor list. So 2x is the greatest common factor of 4x cubed, 12x squared, and 6x. And that is the end of Chapter 10, Lesson 2, Part 2.